Okay, let's take a look at some of the ideas in section 8.3. And I want to talk about um, radical expressions and the fact that they can be added and subtracted only if they have the same index and the same radicand. So, for example, the square root of b has an unwritten index of 2. So that's the only index that's unwritten. And of course, the radicand here is b. All right, so the only time the index is unwritten is when it's 2. Otherwise, the index will be written. So let's take a look at exercise 11 from this section 8.3, where we want to add or subtract the square root of 75 plus the square root of 48. Now both of these radicals have an index of 2, but we see that the radicand of the first radical is 75 and the radicand of the second radical is 48. So they cannot be added at this point. Because they are not in their simplest form, we can't determine whether they can be added at all or not. So all radicals need to be written in simplest form before we're able to determine if they can be added or subtracted. So let's take a moment and simplify both of these radicals and then see, once they're simplified, if we get radicals that can be added or subtracted. Okay, so the square root of 75 can be written as the square root of 25 times the square root of 3. The square root of 48 can be written as the square root of 16 times the square root of 3. So we want to rewrite each radical, if possible, as the square root of the largest perfect square that divides evenly into the radicand times the square root of some imperfect square that multiplies times the largest perfect square factor to give my original radicand. So for 75, 25 is the largest perfect square that divides evenly into 75, and then that has to be multiplied by 3 so that the product of these two radicands is the product of 75. Similarly, 48 is evenly divisible by 4, which is a perfect square, but that is not the biggest perfect square. 16 is actually the biggest perfect square that divides evenly into 48. So we write 48 as 16 times 3. So in this first radical, you always need to have a perfect square, unless the original radical has a radicand that is a perfect square. So this only is used when the radicand is not a perfect square. So the square root of 25 is 5. So that gets multiplied by the square root of 3. And added to that is the square root of 16, which is 4, times the square root of 3. So now we see we have 5 square roots of 3, and we want to add to that 4 square roots of 3. So both of these are square root of 3 terms, so there will be no change to the square root of 3. But the coefficient, I only work with the coefficients. So 5 plus 4 is 9, so I actually have 9 square root of 3's altogether. And so that is my final answer and how it is actually obtained.